Okay, in the previous page, we took the functions and we found the terms. Now we're going to do the opposite. We're going to use the terms to find the functions. So let's read along. Now let's try to figure out the function used to find the nth term given the first few terms of the sequence. All right, now important. Sometimes the beginnings of different sequences will look the same, but it's important to look at all the terms that are given in order to define a sequence. All right, so look at this example. On the left, we got 1/2, 1/4, 1/8, 1/16. That formula would just be 1 over 2 to the nth power, where n is the set of positive integers. If you look on the right, 1/2, 1/4, 1/8, 1/15, very, very similar. But the formulas look way different. So they start off the same way, but end up being very different. All we could do when we are figuring out what the nth term might be is to look for an apparent pattern, all right, what it might be doing. Because we won't have every term in the sequence to check with, all right, just the first few couples. So let's practice that right now. Okay, so write an expression for the apparent nth term of the sequence. So we see it's the odd numbers, all right, 1, 3, 5, 7. And so one thing that helps is to make a table. So I make n is like 1, 2, 3, 4, and then the terms are 1, 3, 5, and 7, and then kind of look for a relationship between n and the terms. So if you notice that there's a constant rate of change, it goes up by 2 each time, then that means it's arithmetic. So you can use what you know about lines to come up with the formula. So that would be like a line if it had the points 1, 1, 2, 3, 3, 5, 4, 7, right? These points right here. You can use 2 of those to write the equation of a line, right? Slope is 2, y-intercept is -1, which doesn't really make sense here. That would be, I mean it does, but the y-intercept would be the 0th term, not the first term. All right, so that would be the apparent pattern for A. Okay, so why don't you try B and C and struggle with it for a minute or two, and pause the video and I'll show you how I do it. Okay, now for B, there is no constant rate of change. All right, the rate of change from the first term to the second term is 3, then 5, then 7. All right, if you ever notice that when you find the changes, if the change of the changes is constant, so it goes up 3, 5, 7. So what it goes up by 2 each time. That means it's quadratic. Now if you look at these terms, they're all 1 less than a perfect square, right? So if we take the nth terms, like 1, 2, 3, 4, all right, and then n, all right, 1 squared, 2 squared, 3 squared, 4 squared gives us 1, which is 1 less than 2, 4, which is 1 less than 5, 9, which is 1 less than 10, and 16, which is 1 less than 17. Okay, so we would just take those squares and then just add 1 to it. And if you add 1 to it, you get the terms of our sequence. So the nth term formula would be n squared plus 1. Okay? Now for C, whenever you have fractions, you should try to write them all as fractions and think of them as 2 separate patterns. So 2 I'm going to write as 2 over 1, then we got 3 over 2, 4 thirds, 5 fourths. Alright, so that's the terms. N would be 1, 2, 3, and 4. So if we look for the nth term formula, we see that the denominator is the same thing as n. Right? On the first term it's 1, on the second term it's 2, on the third term it's 3. Okay? The numerator is 1 more than n. So our formula is going to be n plus 1 over n. So these are all different, but just 2 strategies there, or 3 strategies, just to recap. If it's the constant rate of change like in A, all right, it's linear, use what you know about lines. If the rate of change changes, but it goes up by the same amount each time, like in this one, 3, 5, 7, all right, and 3, 5, 7, that increases by 2 each time, all right, it's quadratic, all right, and then the third method is if you have a fraction, all right, write all your fractions, and if necessary, write them all unsimplified, and look for patterns that way, and think of the numerator and the denominator as 2 separate patterns.